Okay, sorry, video cut off. So we're back to number 12 here. All I've done so far was solve for VIX, and I'm solving for VIY right now because that's what I was given. I was given a velocity initial and an angle of 35. So if I look here, what I want to do is do sine 635 times 65. I get 37.3. So once I find VIY and VIX, I never use those numbers again. So go scratch them out. So let's see what it says here. A, determine the time taken by the projectile to hit ground level. So A, I need to find time. So again, I need to find a strategy here. Okay? I can find the time it takes by doing it yeah, let's do it this way. Since I did it one way on the last problem, I'll do it a different way this one, because there's a whole bunch of ways you can do it. Last time I broke it up to the highest point and then went down. I'm going to take it all at one time. So I'm going to start, this is my initial and this is my final. Okay? So I can't use delta x, they don't give me enough information on delta x. I'm just going to use delta y, I'm going to use y variables here. So I want to label everything I know in the y direction from here to here. Alright, so let's go ahead and do that. So I know VIY is it's launched at 37.3 meters per second. I know gravity is negative 9.8 meters per second squared. I know from here to here, right, that's where it lands, it goes down 115 meters. So I go delta y is negative 115 meters. I want to solve for time. Well, if you look at the equation you'd have to use here, you'd have to use delta y equals VIT plus 1/2 GT squared. Well, VI doesn't cancel out like it usually does, and we'd have to use a quadratic equation. You can do that. You can use quadratic equation. If you don't want to do that, all you have to do is solve for another variable, and then you'll have another one to solve for time. So the only other variable I don't have is the velocity at that point. So if I can find velocity final, I'll be able to use a different equation to solve for my time here. So let's go ahead and do that, because we're probably going to have to solve for velocity final anyways in a later part of this. So instead of solving for t first, let's solve for velocity final. So in other words, what's the velocity at that point right there in the y direction? I look at my variables, I'm going to use this one. Vf squared equals Vi squared plus 2g delta y. Vf is what I'm looking for. Vi is 37.3 squared plus 2 negative 9.8 times negative 115. I'm going to simplify. Alright, simplify that and simplify that. Alright, let me do those. 37.3 squared gives me 1391.29 plus 115 times 9.8 times 2 gives me 4. Add them together. Gives me 3645.29. Last, I do the square root. .4 meters per second. Hopefully you see, oh, Mr. Thomas, that's wrong. Why is it wrong? Well, which way is it traveling at this point? It's traveling downward, right? The velocity at that point is going to be down. It should be a negative velocity. Well, you should remember from one-dimensional motion, anytime you square root, you get actually a positive and negative answer here. So you must remember to look at your drawing and say, oh, I should have a negative velocity here because it's going down. So I'm going to use the negative version of this as my velocity. So the answer to the velocity is it's going to be going negative 60.4 meters per second. So now I'm able to solve for time very easily because I have an extra variable. I know VF. I can use that. All right? So I can simply use VF equals VI plus GT. VF is negative 60.4 equals VI is 37.3 plus negative 9.8 T. I'm going to subtract 37.3 So I get negative 60.4 minus 37.3, and I get negative 97.9. Negative 97.7 equals negative 9.8 t. I divide by negative 9.8. I get time in the air is equal to 9.97 seconds. So from here to here, it takes 9.97 seconds. All right? B says, how far away? So how far is delta x? Right? So that should be relatively easy. Delta x, the only equation you have is VIXT. I plug in delta x. VIX is what I found, 53.2. Time is 9.97. Go ahead and solve here. 53.2 times 9.97 gives me 530.4 meters. Okay, 530.4 meters. Delta x is always easy. All right. C. Find the horizontal and vertical components of its velocity. Okay, what that's asking for is how fast is it traveling in the x direction horizontally? How fast is it traveling in the y direction vertically? So remember, when you find VIX, you know the velocity in the x direction at every single point because it doesn't change. So I can write VFX to be whatever the velocity initial is. So it's 53.2 meters per second. No math required there. And look, we've already found the velocity in the y direction. We've already found it, right? Because we knew we used it over here. So at this point in the y direction, it's traveling, VFY is negative 60.4 meters per second. I've already done that work, so I have those answers. Again, you're just piecing this together. You can solve for basically anything you want up here. You just have to be careful what you're setting initial to final to be. D, it wants to know the magnitude of the velocity. So what this means is this. All right, hopefully you got all this down. I'm going to erase. I need some more room here. You got all this down? So I'm going to write this up here in case we need it later. T is equal to 9.97 seconds. That's the whole time. We already know all that stuff, so we'll go ahead and erase this. So now I want to observe this ball. So we got the ball, or whatever, right before it hits the ground. It has VFX, and it's going down at VFY. We basically want to do the opposite. So we started with a VI and theta and broke it down to VIX and VIY. We have a VFX and a VFY, but we want to get a VF and an angle. So what you do is do vector addition. You slide that head to tail over here. So all I'm going to do is slide VFY over here. This resultant vector is what we call VF. In other words, the overall final velocity. So if you were to put a radar gun on it, it would be traveling this much. The radar gun's not going to say, oh, the velocity in the y is this, and the velocity in the x is that. No, it just tells you how fast it's actually moving in two-dimensional space. All right? So we want to get a value for that. That's the magnitude of the final velocity. Well, if you look here, we have two sides. We know these values. VFX is 53.2, and that's there. So to find the third side, all you have to do, what's this, D, is a squared plus b squared equals c squared. All right, VFX is 53.2 squared plus b is negative 60.4 squared equals c squared. So simplify and simplify. So I got 53.2 squared gives me 2830.24 plus negative 60.4 squared gives me 3648.16 equals c squared. I add them, 2830.24 30.24 gives me 647.8 equals c squared. I square root. Get c equals 80.5. So that ball or projectile is actually moving. You see it move at 80.5 meters per second. All right? Now, DE, what's E say? The angle. So now I need E. So I need a direction. I need to know which way is it going. I need to know what that angle is there. Okay? So you got to use trig. I know adjacent, right? I label my triangle. I know adjacent. And I know opposite. I want to use tangent. I'm finding that angle so I can say it's traveling 80.5 meters per second at an angle of whatever below the horizontal. So I use tan theta equals opposite over adjacent. Tan theta equals opposite is VFY, which is negative 60.4. And it's 53.2. Tan theta equals, do the division, negative 60.4 divided by 53.2 gives you negative 1. Do the inverse tan. Inverse tangent of both sides, and you get theta is equal to. So I do second tan, second answer. You get negative 48.6 degrees. So what that means is the projectile is going 80.5 meters per second at an angle of 48.6 degrees below the horizontal. Okay, that's why it's negative. It starts here, 0. Positive is always counterclockwise. Negative is clockwise. I'm sorry. Negative is clockwise. So that's why it's saying, okay, start here. Oh, it's negative. Go down 48.6 degrees. And that's the direction that the ball, and think about it. If you throw something, it's me traveling that way, right? So if this is the ground, it's me traveling that way. All right, so that should make sense. All right, last one is F. It says, find the maximum height above the cliff top reach. So now I want to go from here to here. I want to figure out this delta y. How high above the cliff does it get? Well, I'm obviously been using y variables. I'll list this up here. I know at this point I'm at 30, VIY is 37.3. VFY at the highest point is 0. I know gravity is negative 9.8 meters per second squared. I'm looking for delta y. All right, let me erase. I need some more room here. So what I want to do here is pick my equation. I'm going to use VF squared equals VI squared plus 2G delta y. VF is 0. VI 37.3 squared plus 2 negative 9.8 delta y is what I'm looking for. Simplify, simplify. 37.3 squared is 1391.29 plus negative 19.6 delta y. Subtract. I get negative 1391.29 equals negative 19.6 delta y. Divide by negative 19.6. So divided by I get 70.9 meters. Okay? So it travels 70.9 meters above the cliff top. Okay? That's kind of the most difficult one you'll get. That includes everything. Okay? So that's a good start. Remember, there's two different types of problems. You have VI and theta. You're going to find VIX and VIY first thing. It says horizontal. You set VIY equals 0 and then start from there. Remember, organize your problem where you only keep X variables together and y variables together. You can't intermix. The only variable that goes both ways is time. All right, good luck.